The topic we are into now is area and volume of similar shapes. In this topic, I would like you to pay quick attention because we'll be discussing very much on two things. One is what we call the area factor. The other one is what we call the scale factor. The area factor and the scale factor, they have a relationship. And the relationship they have is that area factor is the square of scale factor, while the scale factor is the square root of the area factor. We're discussing about area factor and also scale factor. Area factor is the scale factor squared. Whereas scale factor is area factor, the square root of area factor. As we are going into properly solving problems on area and volume of similar shapes, I would like you to pay attention to how we'll be using area factor and scale factor, because we cannot do without them in this topic. The question we are taking in this topic says that two similar triangles have corresponding sides of lengths 4 cm and 7 cm. Now the question now said I should find the ratio of their areas. From this question now, the corresponding sides of these two similar triangles measures 4 cm and 7 cm. As long as it is the corresponding sides, that means the scale factor for the two similar triangles is equal to the ratio of their corresponding sides, which is 4 all over 7. Even if you write it 7 all over 4, you see the same thing. It's also a ratio. Ratio is try to divide something by something. Now, if this is the scale factor and the question is asking for the ratio of their areas, what ratio of their areas means is the area factor. That means area factor. Remember what I told you when I was defining scale factor and area factor? I told you that area factor is the square of scale factor, while scale factor is the square root of area factor. So in this case now, if this is the scale factor, that means area factor is going to be 4 squared divided by 7 squared, which will give us 4 squared is 16 all over 7 squared is 49. We now have to place the area factor now as a ratio, because the question asks for it in ratio form. It's now going to be 16 is to 49, and that answers that question. The ratio to the area of two circles is 4 all over 9. This ratio could also be written as 4 is to 9. They mean the same thing. Then the question says we should calculate the ratio of their radii. Radii is the plural of radius. Question number B said if the smaller circle has radius of 12 centimeters, we should find the radius of the larger circle. Now, in answering question number A, we are told to calculate the ratio of their radii. You know, in a circle, the formula for finding the area of a circle is pi r squared. So whatever figure is given as the area, remember, you have the square of r there. So that is why this figure or this ratio here now, we are going to call it area factor. because they say it's the ratio of the area. If 4 all over 9 is area factor, that means the square root of 4 all over the square root of 9 is equal to scale factor. Because scale factor is the square root of area factor. Square root of 4 is 2, whereas square root of 9 is 3. This can also be written as 2:3. That means question number A, which asks for the ratio of their radii, has been answered. The ratio of their radii is 2:3. Then question number B. Question number B said that if the smaller circle has radius of 12 cm, we should find the radius of the larger circle. We are going to make use of this scale factor now. First of all, let that radius of large circle let the radius of the larger circle be represented by x. Now, if the radius of the larger circle is x, and the question says in B that the radius of the smaller circle is 12, if you have this relationship 12 all over x, radius of the smaller circle divided by radius of the bigger circle, is going to be equal to the ratio of the smaller circle divided by the ratio of the bigger circle, which is 2 all over 3. Remember, in this scale factor, 2 represents the small circle, while 3 represents the big circle. If you cross multiply here, you discover that x is going to be 12 times, or let me do it complete so that you don't be confused. X times 2 will give you 2x is equal to 12 times 3. 3 times 2 is 6. 3 times 1 is 3. If you divide both sides by x, by 2, you'll be left with only x in the left hand side. And the right hand side you have 36 divided by 2. And 36 divided by 2 will give you 18. So that means that the radius of the bigger circle is 18 centimeters. If the radius of the smaller circle is 12 cm, and the scale factor for the two similar circles are 2:3. Question number 3 says that two similar hexagons have corresponding sides of 2 cm and 5 cm. Question number A says we should calculate the ratio of their area. Question number B said if the area of the largest hexagon is 150 centimeters square, that we should find the area of the smaller one. Hexagon. Let me use this opportunity to still give you something you should memorize now. Please, as I'll be writing what I'm writing now, write it down by your side and try to memorize it. Try to cram it. What is it? Figures that have 3 sides are called triangles. You know that one? So we have triangles. Three sides. Figures that have 4 sides are called quadrilaterals. Quadrilaterals. Four sides. Quadrilaterals. It includes square, it includes rectangles, it includes parallelograms, It includes trapeziums. They are all quadrilaterals as long as they have 4 sides and 4 angles, unlike triangle that have 3 sides and 3 angles. After quadrilateral, you have what we call pentagon. Pentagon. Pentagons have 5 sides. After pentagon, you have hexagon. It was this question that reminded me to write this for you, because I know that in most cases students used to have this problem of knowing which is which. After pentagon, you have hexagon. 6 sides. After hexagon, you have heptagon. Heptagon. Heptagon have 7 sides. After heptagon, you have octagon. Octagon has 8 sides. After octagon, you have nonagon. Nonagon has, or they have 9 sides. Then the grant for O level is decagon. Decagon has 10 sides. At least at this level, you should memorize this. There can be figures that have 11 sides, 1 million sides, 300 sides. It's possible. But in calculation, as far as O level is concerned, memorize this. Triangle, 3 sides. Quadrilateral, 4 sides. Pentagon, 5 sides. Hexagon, 6 sides. Heptagon, 7 sides. Octagon, 8 sides. Nonagon, 9 sides. And decagon, 10 sides. Please memorize it. I'm going to clean this off because it is not part of what we are doing. I hope you have memorized it. Okay, 2 similar hexagons have corresponding sides of 2 cm and 5 cm. Calculate the ratio of their area if the area of the larger hexagon is 15 cm squared. Find the area of the smaller one. Calculate the ratio of their area. They told you that the corresponding sides are this and this. That means the scale factor is equal to 2 all over 5. And the scale ratio is 2:5. Ratio of their area means area factor. And area factor is scale factor squared. That means ratio of area is now equal to 2 squared all over 5 squared, which is something as 4 all over 5. And 4 all over 5 as area factor means 4 is to 25. 5 times 5 is 25. 4 is to 25. So this is the ratio of their area. Question number B. Question number B said, if the area of the larger hexagon is this, area of larger hexagon is this, find the area of the smaller one. Start by saying, let the area of smaller one let the area of smaller one be represented with any letter. Let's use Y now. Area of larger one is 150. So area of smaller one, which is Y, divided by area of larger one, which is 150, will be equal to their area factor. And the area factor is 4, representing the smaller, all over 25, representing the bigger one. If you cross multiply here, you'll be able to find the value of Y. 25 times Y will give you 25Y. And it's going to be equal to 4 times 150. 4 times 0 is 0. 4 times 5 is 20. Write 0 and carry 2. 4 times 1 is 4, plus 2 will give you 6. That means 4 times 150 is 600. If you divide both sides by 25, you'll be left with only Y in the left hand side. And in the right hand side, you're going to have 600 divided by 25. Use a calculator there, don't crack your head. 600 divided by 25 is giving me that Y is 24 centimeters squared. Remember, they ask for the area of the smaller one. The figure is going to be in centimeters squared. The shape of a Maggi, the shape of a Maggi cube, and sugar cube. That is the shape of a cuboid. Cuboid is something like this. That is a cuboid. Okay, they say that the corresponding width of similar cuboids measures 11 cm and 9 cm. 11 cm for the larger one, 9 cm for the smaller one. Here say we should find the ratio of their area from the scale factor which the size has given. Find the area factor. When you find the area factor, put the area factor as a ratio. You have answered question number 1. Question number 2 says we should find the area of the smaller cuboid if the area of this bigger one is 363 centimeters squared. So let's start. Scale factor. Is equal to 11 all over 9 or 9 all over 11, whichever way. This is the scale factor. Then question number A says we should find the area, a ratio of their area. First of all, find the area factor. Area factor is the square of scale factor. And it's going to give us 11 squared divided by 9 squared. 11 squared is 121. Let's confirm it. 11 times 11 is 121. So we have 121 all over 9 squared is 81. You can still confirm it. 9 times 9 is 81. That's correct. So this is the area factor now. Then the ratio of their area, the ratio will now be 121 is to 81, or 81 is to 121. They are the same thing. This answers question number A. Then question number B. Question number B says that the area of the smaller cuboid, if it is, sorry, we should find the area of the smaller cuboid if the area of the larger cuboid or bigger cuboid is 363 centimeters squared. Let the area of that smaller cuboid be represented with a letter. That's how you start. Let the area of the smaller cuboid be represented with X. Area of smaller cuboid. That means X, which is the area of this smaller cuboid, divided by 363, which is the area of the bigger cuboid. 363 will be equal to the area factor now, which is 121 all over 12, all over 81. But be careful, x represents the area of the smaller. That means you're going to have 81 up and 121 down, because the area factor, in the area factor, 81 is representing the area of the smaller one, while 121 is representing the area of the bigger one. So with this relationship now, you can cross multiply. When you cross multiply, you have x times 121, which will give you 121x. And it's going to be equal to 363 multiplied to 81. Let's multiply out this. 363 multiplied to 81. The value is 29,403. That is 121x. If you divide both sides by 121, you'll be left with only x in the left hand side of the equation. And in the right hand side, you have 29403 divided by 121. Let's divide. Divided by 121 is giving me 243. That means x, which is the area of the smaller cuboid, is now equal to the value we got by dividing 29403 by 121, which is 243. It's going to be in centimeters squared. And that answers question number B. The fifth question says that the map of Lagos State is drawn to a scale of 1:50,000. On the map, the Murtala Mohammed International Airport means Murtala Mohammed International Airport covers an area of 8 centimeters squared. Then we are asked to find the actual area of the airport in hectares. Okay? Let's start by the scale. This scale is a representative of the scale ratio from scale factor. That means our scale ratio or scale factor. Let me use the one you are conversant with. Scale factor is equal to 1 all over 50,000. The ratio on which the map was drawn, 1 over 50,000. Now, what is the question asking for? The actual area of Murtala Mohammed International Airport, if its area in the map is 8 centimeters squared. From here now, our area factor is going to be 1 squared all over 50,000 squared. 1 squared all over 50,000 squared. Let's calculate it here. 1 squared is 1 all over 50,000 times 50,000. It's giving me 2500, then 6 zeros. 1, 2, 3, 1, 2, 3. So this is the area factor. The area factor of the statements. Now, they're asking for the actual area of that airport. If inside the map the airport measures 8 centimeters squared, start from let the actual area be represented by a letter. Let's use X. Now, if you look very closely now, you discover that this X now is the area of the real measurement of the airport on land, which is bigger than what the measurement is inside paper. That means X, which is the actual area on land, divided by the area factor that represents the actual measurement on land, which is 2500,0000. This is going to 2,500,000,000. It will now be equal to, come to the area factor. Now, this is the actual measurement on land. You have divided it with what the representative of the actual measurement of land is on the map or on the scale. Now it's going to be equal to 8, which is the measurement inside map, and it's going to be divided by 1, which is the representation of the measurements in map. So as you have this now, if you cross multiply, you discover that X times 1 will give you X. X is going to be equal to, just multiply 2,500,000,000 by 8 times 8. This is the kind of figures that students will see. They will tell you they don't know the meaning. But what this means from this calculator is 2 times 10 exponent 10. And that will be 2 and 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the kind of figure you see in Ministry of Lands when it comes to land measurement. But this is still in centimeters squared. 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's try to limit. This is 20 billion meters squared. But the question says we should give the answer in hectares. So we're going to convert 20 billion centimeters squared into hectares. First of all, 10,000 centimeters squared is equal to 1 meter squared, and 10,000 meters squared is equal to 1 hectare. Therefore, 10,000 times 10,000 centimeters squared is equal to 1 hectare. Let's use this as abbreviation for hectare, and that will give us, write down the first 10,000. Now bring in 1, 2, 3, 4 zeros. 1, 2, 3, 4. You have 1, 2, 3, 1, 2, 3. 100 million centimeters squared is equal to 1 hectare. 20 billion centimeters squared to hectare, because the question says we should give the answer in hectares. So the parameter is that 100 million centimeters squared, 100 million centimeters squared is equal to 1 hectare. What we have here is 20 billion centimeters squared. So therefore, 20 billion has 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters squared is going to be equal to 20 billion divided by 100 million. So we have 20, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 100 million. 1, 2, 3, 1, 2, 3. Whatever you have here now is in hectares. So let's divide out. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. So we have 200. So the actual measurement of the Murtala Mohammed Airport represented by X, which we got formally to be 20 billion centimeters squared, is 200 hectares. And that brings us to the end of that question. Question number 6 said that a picture of size 8 centimeters by 10 centimeters costs 44 naira. We are asked to calculate the price of an enlarged picture of size 20 centimeters by 25 centimeters if price is directly proportional to size. That reminds me, proportion may be the next thing we are going to treat after this, but I will use a glimpse of an idea from it to solve this question. Something is directly proportional to another thing if, as the first thing increases, the second one also increases. That is when you say that the two things are directly proportional. For instance, if you want to go to the market and you want to buy rice in cups, if one cup is 3 naira, that means 2 cups is 6 naira. 3 cups will be 9 naira. 4 cups will be 12 naira. 5 cups will be 15 naira. You can say that the cost of a cup of rice, or the cost of rice, is directly proportional to the number of cups, because as the number of cups increases, the price also increases in equal proportion. So in this case now, they say that the picture size of 8 by 10 centimeter costs 44 naira. The area of that picture is area of the picture is 8 times 10 centimeters squared, which is 80 centimeters squared. Then the area of the enlarged is going to be 20 times 25. Let's multiply that out. 20 times 25, 500. Centimeters squared. Now, if 80 centimeters squared costs 44 naira, therefore 500 centimeters squared will cost 500 divided by 80 of or times 44 all over 1. If the size is proportional to the price, that is directly proportional to the price, that means this our relationship will be correct. If it is inversely proportional, this our relationship is not correct. Okay, don't worry, when we get into proportions, you're going to understand what I'm saying. I don't want to go deep into it. Let's multiply at 500 times 44 divided by 8 It's giving me 275 naira. That is going to be the cost of enlarging that picture that was formerly 8 cm by 10 cm to 20 cm by 25 cm, as far as the price is directly proportional to the size. Says, assuming two different square floor tiles are made of the same material. One has side measuring 30 centimeters and the other measures 50 centimeters. They were asked to calculate the price of the larger tiles or tile if the smaller costs 90 naira. As long as they say that the tiles are made of the same material, that means the prices will be directly proportional to the sizes. The first tile measures 30 centimeters. That means the area of that one, because they said they are square floor tiles. Their length is equal to their width. That means the area of the first one, or small one, is equal to 30 times 30. Centimeter squared, which will give us 30 times 30 is 900. But let's confirm. 30 times 30. We are correct. 900 centimeters squared. Now, the second tile, they say it measures 50 by 50. That means area of bigger. Area of bigger or larger tile will now be 50 times 50 centimeters squared. And 50 times 50 centimeters squared is 2,500. Let's confirm. 50 times 50 is, we are correct. Now, the question is now telling us that if the price of the larger tile, so we should calculate the price of the larger tile, if the smallest costs 90 naira. That means a tile with an area of 900 centimeters squared, the area of the small tile, will cost 90 naira. Therefore, in direct proportion, the tile with area of 2,500, the area of the bigger one, centimeters squared, will cost 2,500 divided by cost of the smaller one, which is 900 times 90, all over 1. Let's multiply of 2,500 times 90. I'm multiplying the numerators, then divided by 900. It's giving me 250 naira. And that is the answer to that question number 7. Question number 8 says that the area of the windscreen of a lorry measures 1.21 meters squared. A picture of the lorry is taken, and the windscreen appeared as a rectangle measuring 3 cm by 12 cm. Question number said that we should calculate the real length and breadth of the windscreen. Let's start by the real area of the windscreen. Real area is equal to 1.21 meters squared. Then the area of the windscreen in picture on real area of the windscreen is going to be 3 by 12. That is 3 times 12. This is in centimeter squared, which will give us 3 times 2 is 6. 3 times 1 is 3. 36 centimeters squared. Now, let's unify the units. Let's make the units have the same, let's make the figures for the two areas have the same unit. Some students used to make mistake. 100 centimeters makes 1 meter. That's correct. But 100 centimeters squared is not equal to 1 meter squared. Rather, 10,000 centimeters squared is equal to 1 meter squared. Now, if you want to convert 121 meter squared to centimeter squared, you multiply 1.21 meter squared by 10,000. And if you do that, just move the decimal point across 1, 2, and add 2 zeros. So it's going to give you 12100 centimeters squared. That is the area of the real windscreen. The area of the unreal windscreen is 36 centimeters squared. Area of the unreal. The inside picture. Now let's find the area factor. The area factor from here, from the two area now, is going to be 36 all over 12,100. Or it can be 12,100 over 36, whichever way. That is the area factor. Wanted to write area factor, I wrote area only. So the area factor is equal to 36 all over 12,100. That means the scale factor, which is the square root of area factor, is going to be the square root of 36 all over 12,100. The square root of 36 we know to be 6. Let's use calculator and find the square root of 12,100. Square root of 12,100. 110. That means 110 times 110 will give you 12,100. Now that I have found the scale factor, let's go back to the question. The question said that we should calculate the real length and breadth of the windscreen. This is our scale factor now, and this is the length and breadth of the windscreen inside picture. So let's say, let's the real length. Let's start from the length. Let the real length be represented by x. This x divided by, remember that the x is the real length, divided by the unreal length, which is the length inside picture. 12 will be equal to the representation of the real length in the scale factor, which is 110, all over the representation of the unreal length in the scale factor, which is 6. If you cross multiply, x times 6 will give you 6x. And it's going to be equal to 12 times 1/100. Let's multiply out this. 12 times 110. That means 6x is equal to 1,320. Only x, dividing both sides by 6, is going to give you 1,320 divided by 6. And x, which is the real length, will now be, let's divide this out, 220 centimeters. That is the real length now. Now we are going to calculate the real breadth. Remember the question said we should calculate the length and breadth, the real length and breadth of the windscreen. Start by saying, let the real breadth be represented by, let's use y now. That means y, which is the real breadth, divided by 3, which is the unreal breadth, the breadth inside picture, is going to be equal to, come to the scale factor again. Y is representing the real, and you are divided it by the unreal. 110 is representing the real on the scale factor. So you're going to be 110 all over 6 is representing the unreal on the scale factor. So you now have 110 divided by 6. If you cross multiply, discover that y times 6 will give you 6y. And it's going to be equal to 3 times 1, 110. 3 times 0 is 0. 3 times 1 is 3. Times 1 again is 3. If you divide both sides by 6, you have only y left in the left hand side, and it's going to be equal to 330 divided by 6. And with a calculator, 330 divided by 6 is 55. That means the real length is 220, while the real breadth is 550. I want us to check something. Let's find out if, remember, the real area is 12,110. Let's multiply this real length with the real breadth and see if we get this. If we do, that means what we calculated is correct. 220, the real length, times 55, the real breadth, is equal to 12,010. That means we are correct.